The floor is yours. Hello, everyone, and welcome, and I'm glad you could all join us today. I'm sure many of you are living in big snowstorms, so thanks for taking the time today. I just wanted to welcome you to our session today. It's going to be about joint connections using Autodesk Inventor 2014. My title with Ascent is Instructional Design Project Manager, and basically what that means is that I manage the development of all of our Autodesk curriculum. So I work with all of our developers, developing and understanding all the timelines to get folks updated and getting all of them published out to all of you. Specifically, I'm responsible for the manufacturing suite of products, so I deal with all of the Inventor titles. I also deal with Navisworks, Showcase, and Plant 3D as well. So with that, I want to jump into the presentation and just tell you a little bit about the layout of the session today. So this material is coming directly from our Autodesk Inventor 2014 Introduction to Solid Modeling class. This is Chapter 17. It's Joint Connections. So this is new functionality within Inventor 2014. So many of you have probably joined us today because you'd never heard of this topic. And yes, it's absolutely new in 2014. So we'll jump into this, and I'll show you what we're going to do today. So like everything, I want to start out with an objective. So the objective today is simply really one. We're going to use the joint command to connect components in an assembly, maintaining a defined degree of freedom. So basically, we're going to learn how to use joints to allow for the required degree of freedom when we assemble two components. So as you all know and have used in Inventor, prior to 2014, the constraint tool and the assemble tool have been available to us, and those enabled you to individually remove degrees of freedom between components with the ultimate goal of assembling them. With joints, it's a little bit different and a lot more efficient because it enables you to define and select a single degree of freedom or a single type that allows for the degree of freedom you're going to want. So I got two little videos here I'm going to play for you to kind of show you where we're going to go with this today. So this very first video I'm playing is just a simple little rigid constraint. So I'm basically selecting my components. I'm going to play that again, selecting the two references on the two components, and it will assemble them together using that rigid constraint. And they've got a little jiggle that happens at the end, and that little motion is something that I actually really like, and you'll get to understand throughout this presentation. It's telling me that I've got a rigid connection between those two, so that it's basically removing all of my degrees of freedom. In the second one, I've not got the references shown, but what it's showing is the slider joint type and the allowable motion after it's been used. Okay, so that's what we're going to do today. We're going to create assemblies using the joint command. So as I mentioned, the joint command constrains components in all your required degrees of freedom with one simple connection. So that's the key here, one, not two or three like you would use using the constrain and assemble tool. So it's an absolute replacement for constrain and assemble. And we'll learn a little later that you also can work with them together. The one thing you want to do with the joints is that you actually are determining your allowable movement and selecting the type to allow for that movement. Unlike with constrain and assemble, you actually think of what you want to remove as possible degrees of freedom, and then you assign your constraints based on that. So there are 6 types that you can select from, and I've got them listed here. But what I want to highlight here quickly is how you activate this command. And you can see here it's directly in the assemble panel, the assemble tab, and it's the joint option. And it's right beside constrain. It's right beside it, so it's very easy to locate. So those 6 types, what do they allow for? Basically, each one of them allows for a certain number of degrees of freedom. The very first one, and that's that very first video I showed you, rigid, it eliminates all of your translational and rotational degrees of freedom. So if you look in the image that I've shown here, if you draw your attention directly here where I'm circling to the pin that's right in here. That is being assembled with a rigid constraint, or sorry, a rigid joint that's eliminating all my degrees of freedom. And here on the right, the rotational joint, I'm looking at this arm, and you can see this green arrow here. That's showing me what degrees of freedom remain. So there's one rotational, so this arm can rotate about that pin. And that's done with just one joint connection. Slider, you also saw this in the video up front. And again, if you look at the green arrow here on my image, it's showing you the degree of freedom that's still allowable with this joint connection type. And then cylindrical, this one allows for one translational and one rotational, so you can see both green arrows here that I've got circled, and that's allowing for that pin to move in and out, as well as rotationally around the housing. And the last two that we have are planar and ball. So planar allows you to rotate around a single plane as well as move translationally in two directions. So again, looking at these green arrows that I've got highlighted, as well as the rotational one there that is shown around the central axes. And then the final one, ball. And this is a great example here with this image that I've got here. It's showing a ball within a socket, and it's allowing for the 3 degrees of rotational degrees of freedom. Okay, so those are the 6 types that are available to you when you're using this command. So how do we do it? This is a really fantastic command, a great replacement to the constraint tool. So how do we get there, and how do we create these joints? It's really a simple 5-step process. Basically, I've listed them out here, and I'm going to go through each of these. It starts with simply initiating that joint command, selecting which type. So I just explained the 6 different types. You would pick one of those types. You would then also select references. So you define how the 2 components are going to come together and what references are going to be joined. Then you can define some additional options, and then you simply complete the joint. And when you complete the joint, the 2 pieces are together, and you can actually drag within the model to test that degree of freedom. So this is a really great tool for testing the function of your assembly. So in terms of initiating that joint command, we mentioned it's on the Assemble tab in that Relationships panel, so right beside the Constrain tool that you're all familiar with. And when you initiate that command, it opens the mini toolbar, which we have here in the image on the right, so right here, and also the Place Joint dialog box, which also appears. Now, just like many features within Inventor, you have the option of using one or the other. So myself today, I'm going to be really trying to focus on the mini toolbar. I find it the most efficient way of working. However, there are a few commands that the mini toolbar doesn't allow you to do. And I just want to draw your attention quickly to those. So to start off with, it enables you to name the joint. Always a fantastic idea when you're assembling all your components. Assigning a descriptive name helps you identify which joint it is. It also enables you to replay the animation. So that little jiggle that I saw with the rigid constraint or the rigid joint, the slider little slide view animation, so this enables you to replay it. So sometimes if you miss it or you want to replay it, you do have to do that play button within the Place Joint dialog box. And finally, limits, and this is a fantastic option. So in that slider option that we talked about, the animation showed a little range of motion which maintained within the actual physical part. However, in actual fact, that could actually drag right through my model, so it doesn't recognize interference. So with that Limits tab, you can do that. You can set range. And then we get into selecting the type. We've already talked about the type, so I don't want to focus too much on that. We've got that, but just where you get that, where you actually assign it. And you do that both in the mini toolbar using the drop-down, pull-down, as well as over in the place joint dialog box. Okay, so there are two different drop-downs, and you've got all your 6 options. Now, I'm sure all of you see this additional one here, automatic. What is that about? Identical to what you've used in the constraint tool. So it's basically relying on the system to determine which constraint or which joint should be done based on your references that you select. I myself personally find that more often than not, if I use automatic, I'm not getting what I want. So I recommend using the 6 to get started and get comfortable with it, and then you can look at using automatic, and you probably get to figure out which ones they're most effective for. So then once you've picked your type, you have to define your references. And that, again, can be done in either location, so the mini toolbar as well as the dialog box. And what you're going to do is you're going to focus on one line first, the connect area first, and then followed by the align. When you define your references, you are able to define it based on faces, edges, as well as spherical geometry. So I'm going to get in and I'm just going to show you what those look like. So in terms of a face, what it's doing is when you hover your mouse over the component that you're going to constrain, over the face, it highlights the edges and it highlights connection points. So you can see in my 2 images at the top, I've got my corners all highlighted here. So each of the corner has a red little dot, so that's identifying that is a possible connection point. The midpoint as well is highlighted as a possible connection point, as well as the center point as a possible selection point. And depending on which one is active, the way that is determined is simply where your mouse is hovering. So in this situation, you can see where my mouse is. It's located very close to that center point, or sorry, the center point of that edge. So that is my connection point. So that would be the reference that would be connected on that component. And over on the right here, you can see I've moved my mouse a little bit closer to the internal center point, and then that one highlights. So the key here is remembering that the green cursor is what you're looking for, the green highlighted dot. Edges are the same way. So here I've actually put my mouse directly on an edge, and in this situation my connection points are the 2 endpoints, or it can be the center point as well. So one of those. Here in this view, I've got the center point highlighted. And then for a cylindrical surface, or circle, for that edge, because there's no actual points on the exterior circle, you only have the ability to connect with that center point. So key there, again, just watching for the green dot, and that's going to be your connection point. Spherical geometry, you have 2 options when you're doing this. The first one is the center of the spherical geometry, and that's what I have highlighted in my left-hand image. So right here, the center point is highlighted. And in my right-hand image, it also identifies any intersecting geometry. So here, I am intersecting with this circular extrusion, so it's picking up the center point, that intersection point. So that would be my connection point for those with that component as I'm connecting. So those are the reference types you can select. And then you're going to work over in I have got the mini toolbar displayed here. You're going to work in the connect area. Okay, that's going to be your first area. So you are selecting those green dots on both components. Okay. The align option, the second one here, is actually more of an optional constraint area. Basically what that means is it is only enabling you to orient the model if it doesn't come in correctly. So I have found, and you'll see in my demonstration, that most of the components that you connect actually do a fantastic job on assuming the orientation correctly. So in many cases, the align option isn't actually required. However, it can be used in tandem with that connect option to orient it properly. And again, it would just be bringing up the ability to select any of those edges, those faces, or to orient by. One thing here too, in the Connect, this is the flip button. So, you know, we always have seen the flip option in many different tools within Inventor. This is the flip option here. So if the two components don't come in the right orientation, the two edges, the two faces, you can just flip those and it will clear it up and reorient it properly. Just some general notes at the bottom of the page here. The reference selection order that you use is important, and it does affect the model orientation. So you'll definitely want to make sure that your very first reference that you're selecting is the one that is going to be moved when it's finalized, okay? One thing, too, to think about is when you move your grounded component, it is not going to remove that grounded status, okay? So it does stay grounded, so something to consider. If you do select it for moving, when you assign a constraint, the joint, it will prompt you and say that you're trying to do this to a grounded component. The fourth step, so that workflow that I talked about, the fourth step is defining any optional options. So this enables kind of the ability to use two different commands here. And one of them is gap. So just like in the constraint tool, we defined an offset. So if you were mating two faces or aligning two faces, you could set that offset value. The same holds for using the joint command as well. So that is a gap value. So they just call it gap instead of offset. And then we mentioned briefly the ability to set limits. So in this example here, if you look at this little animation I have, that slider is in the preview animation is only sliding, you know, within a few inches of the assembled position. However, once we finalize it, we could drag it through, and interference is not considered. So that limits could be set here, where you could go in and set the linear control here, where you start and your end point. And then you can complete the joint. So you've done all your references, you've assigned the type, you can complete the joint. So you could enter a name for it, definitely a recommended in the workflow. And then you select OK, or you select a checkbox. So those ways of completing the feature are identical to what you would do in completing any other feature. There are two commands here as well that I want to draw your attention to. And those are the lock and protect commands. And I've got them here highlighted in my model browser. And what they enable you to do is add a little bit more control to it once it has been assigned to your model or to your component. The lock option enables you to maintain the current position, but it does not disable the degrees of freedom. So basically you cannot move a locked component, but it enables you to maintain any other connection points, okay? So you can't move that component, but if other components require its movement, it will reflect that movement. You just can't use it as the source for moving. Protect is another one, and this one's a nice one, as it actually warns you if you're going to violate the degrees of freedom restriction that you've put on with the joint that you've added. Okay, so what I want to do now is jump over to Inventor, and I have an assembly that we're going to put together. And I'm just going to show you a quick animation here of what we're going to work to achieve here. So this is a propeller assembly here. We're going to work to assemble all of the components using this new 2014 joint command. Okay, so I'm here now in Inventor. I have an assembly started. I've just simply started it with a default template. And I'm going to start by assembling one of my components. And the very first one I want is my block component. And you can see that it comes in 2D. I'm just going to flip that into a three-dimensional view and then drag it onto my screen. And before I finalize its placement, I just want to mention a couple 2014 enhancements here because this is fantastic. If I right-click here, I have a couple different new commands available to me. And what is wonderful about these is it allows me to rotate the model into position that I'm going to want to use as my home and default view. So I'm right now in my home view. I'm going to rotate the block by 180 degrees about my x-axis, and I have it located here. You also have the ability to place your first component now ungrounded. And prior to 2014, you actually had to place it as grounded, then you'd have to go in and turn that grounding off. But what you can do now is you can right-click and select Place as Grounded at the origin. So I'm going to place this as a grounded component. And there we go. We have my first component. You can see over in the model browser that it is grounded. The next component I am going to place is my cylinder. Okay, and once I bring this in, I also am going to rotate this. So I'm going to rotate this again around 180 degrees and place it. And I'm just doing that more for ease of assembly so that I can easily see the components and the references that I'm going to need to pick. And now it's time to actually define the joint that I want to add. So I'm going to go up into my toolbar. So I've got up top, I've got the joint command activated. The little tooltip is displaying. I'm going to select joint, and you can see that I have the place joint dialog box as well as my mini toolbar displaying. I'm going to pull this drop down and assign the rigid constraint type. So I'm going to add a rigid joint. And then the next step, if you remember, step 3 in that process is to select my references. So as I roll over and hover over my model, you can see that that outside edge is highlighted, and the connection point is the center of that edge. You can see the green dot. So I'm going to select that to activate it, and I'm selecting that on the component that I'm going to move. And then I'm also going to do the same thing on my grounded component. And you can see that it moves into position, and I got that little jiggle that's showing me that there's no degrees of freedom left, and I've assigned the rigid joint. So I'm going to select OK, and I have my components now assembled using that joint constraint. If you take a peek over in the model browser, so I'm going to expand out the browser here, and I'm going to just circle here the rigid constraint that's been added. Okay, so you can see it's listed here in the model browser. So the next component that I'm going to assemble is part of the crankshaft. So I'm going to assemble a couple components at the exact same time here, just for ease of selection. Again, I'm going to rotate it, and I'm going to place it. And I can, because they're not constrained, I can drag this out a little bit. I'm going to zoom in so you can see this a little bit better. And for this type, I'm going to actually, for these components, I'm going to add, I'm going to move my mini toolbar over. And for this one, what I'm going to do is I'm going to add a rotational joint. So I've selected that here. And again, I'm going to select my, my references to connect the two components. I want to move this master rod here, so I would select the edge, and that center point is highlighted in green. And on this one, I'm actually going to select the outer surface. So you can see here, the outer surface, I have the end point, the center point, or the other end point. So I'm going to keep my mouse closer to the center of the pin here and select. And you can see that my component now moves into position. So I'm going to replay that animation. You can see that it rotates beautifully. So I've got it all assigned properly. So I'm going to select OK. Now one thing here now, if I try and select this component, I actually can't drag it. And the reason why that is because this crankshaft is not grounded. So I'm going to temporarily ground it just so that I can test the function of my assembly. And now you can see that I can actually drag that component. And I have that rotational, the rotational joint assigned. The next components I am going to do now are the piston head pin and the piston head. Bring these in. Again, I'm just going to rotate. This time I'm going to rotate about the Y. and just bring them into position so I can see them and easily pick my references. And the constraint type that I'm going to do here is another rigid. So I want to basically weld these components together so there's no degrees of freedom left. So I'm going to use rigid. And I'm going to select the endpoint. So I've got one endpoint here. You can see as I've highlighted here, I've got the center point connection as well. I'm going to do the same thing on the piston head. Okay, so it moves into position. You can see by the animation it is assembled to remove all the degrees of freedom. However, you can see that it actually is oriented in the wrong direction. So this is one situation where I need to go up to my mini toolbar and I need to select that flip component option. So I'm going to select flip component, and you can see that it flips in the model. Okay, so keep in mind here that I've not used the align option at all. All of my components are coming in beautifully. They're not having to be aligned at all. I'm going to zoom in a little bit here, and you're going to see that there's a bit of overlap here between the pin and the cylindrical surface of the piston head. So this is where I need to enter a gap value. So I'm going to enter a value here up in my mini toolbar. You can see that I've entered it right up here, 0.05. And I've just hit escape, which is what takes me out of the command. So I'm just going to do this again quickly here. I'm going to assign my rigid constraint here and here. Again, it's going to flip it into position, and I'm going to enter my value. So what I did there in terms of, I just ended the command by accident by hitting the escape key. So just like any other command, if you hit escape, it terminates the command. So I'm going to select OK here, and I now have my pin assembled properly. If I select the pin to drag it, you can see that the piston head moves with it. So next one is to assemble that piston onto the master rod. So here I'm going to rotate or select the center point of my pin and the center point up here on the master rod. And you can see what happened there. So it is, I actually by mistake left the automatic command on there. And I actually did that on purpose to show you that sometimes the system doesn't actually select the correct one for you. And in this case, it determined that it thought that I needed a cylindrical reference or cylindrical joint, and that's not what I wanted. And I can tell that by the motion on that animation. Instead, I want to do a rotational, and I can just change that up very easily and do that. The other thing that you'll notice here is that only the pin moved with it. So that piston head was left over here. And that is the case when you're doing the preview. So whenever you're previewing and still live in the actual joint command, it only takes the component that was selected as the reference. So when I select OK here, that head, the piston head actually goes with it. And then you can see that I can actually drag everything together. Okay? So here's a better movement there. I can select the master rod and do it that way. So now what I need to do is I actually want to assemble these two components to one another. So I've got my rigid component that I assembled, the cylinder head, to the grounded block. And now I want to bring over all of the piston assembly. First thing I'm going to need to do, though, is I have to unground that crankshaft. So I'm going to right-click and select grounded. And now you can see that it actually drags as one whole piece. And it will allow me to then assemble things. So I've got my mini toolbar up. I have executed the joint command, and this time I'm going to select a cylindrical type. And I've selected that now. I am able to pick my references, and I'm going to reference the piston head here, the center point, the connection point at the center, as well as the center point of the block. And you can see here that I have a cylindrical motion, which means I have a degree of freedom that translates and rotates. And I can select OK, and you can see that it constrains inside of the block. But you can see that I've got kind of a wacky movement here with the rest of the component. So it's just not maintaining the rest of it. So what I'm going to do now is I'm going to constrain the pin, or the shaft now, with respect to the block as well. I'm going to make this just a touch bigger so we can see it. And here what I want to do is also assign a cylindrical constraint. And I'm going to pick the center point of the piston head here, or sorry, the piston rod, as well as over here in the block. So I've got my center points. Okay, so it goes into position there. I'm going to flip that so that it actually goes the correct direction. And you can see here that I've got that motion that goes all the way along. And it's eliminated the use of all of the others. So I'm going to select OK at this point, and everything snaps beautifully into position. So you can see how now I have everything exactly where I want it. So I can go in here now, and I can drag that master rod, and it will update all of the components. I've got the rotation going on with the piston head as well as the rod. Okay, so that's how that works. So I've used lots of different constraints, lots of different joints to assemble that. So the next portion of this assembly is going to be actually that propeller head. So we saw that in the video. And the two components that I'm going to use first are the hub and the shuttle. I'm going to bring those in and leave those like this. You can see that I've got those added. Now, I know many of you use the free move button and the free rotate, and you can still use those to orient models independent of one another, so I can get those into position so I can better select the references when I define my joint. So I've just done that. And I'm going to start by adding another joint, and this one is going to be a rigid type, so no degrees of freedom. And I'm going to select, rotate this slightly, I'm going to select this surface, and I'm going to get, if you move my mouse around here, you can see that the connection point highlights at the center. So it is really key that you actually move your mouse around, and I've got the same thing happening on the end there, so I've got that in position, and you can see that it moves into position there. I've got that little jiggle, so I play my animation, that's showing that it is a rigid constraint. So I can select OK. The next one is that the shuttle piece, and this one is done with a cylindrical, and this one's going to be interesting, so definitely pay attention to this one. With cylindrical here, I'm going to also select the surface. I'm going to select that center point as my connection, and I'm going to do the same thing on the shuttle here, or the hub, sorry, and I've got my point there. You can see it moves into position. So I've used the cylindrical constraint, and you can see that this allows me to move it in and out. So I've got interference happening here, as well as rotated, which also gives me interference. So now I've got to clear that up to make sure that I'm constraining that component properly. And this is what's really fantastic about the joint. It actually enables you to work in conjunction with some constraints as well. So I'm going to activate the constraint tool at this point, and I'm going to add an align constraint, or sorry, an angle constraint with a directed angle solution. And I'm going to select some of my references. And I'm going to do that directly in the hub. I'm going to select work plane 1. And over in the shuttle, I'm going to select one of my origin planes. And you can see that it now is locked in position. However, I still have interference, so I'm going to actually change my angle to give me no interference in that model. So you can see now that I have assembled. If you look in my model browser, I'm going to just circle it here at the bottom of the page. I have my cylindrical joint as well as an angle constraint. And if you look at that now, it doesn't rotate. However, I still do have that interference being possible. So if anyone can remember back in the joint connection dialog box, the limits tab, we can go in and actually edit that cylindrical joint. So I'm going to hit edit, and I'm going to use that limits tab. This is one of those commands that you can't do anything for in the mini toolbar. So I've activated that limits, and I'm just going to enter some values in my linear field here as well. So a start basically and an endpoint, which is going to limit the motion from the selected references that I defined. So I'm going to select OK here, and I'm just going to rotate my model a little bit so you can see this a little better. And you can see that it now rotates, and it actually moves only as far as those limits permit. Okay, so the key there was the joint command enabled me to use also use constraints. So I had used the cylindrical type. However, that it allows you to work in conjunction and add a constraint as well to remove that 1 degree of translational, rotational degree of freedom that I didn't want anymore. Okay, so the next one that I'm going to assemble will be the last two, and then we'll look at a final assembly. And basically what this one is the blade. So I'm going to bring in the blade and the connecting rod that are joined with it. So you can see here now I have one instance of each in my model. Again, use the joint command. I'm going to close this place joint dialog box at this point because I want to just show the model a little bit better. I'm going to add rotational here. So this is going to be the blade attaching to the rest of the assembly. And I'm going to select that center point as the reference, so that connection point. I'm going to do the same thing over in the model. And you can see that it moves into position quickly. So I've got that rotational movement. I'm going to select OK here, and you can see that I can drag that into position. If I use the joint command again, the next one that I actually have to do is a ball joint, and this wasn't one yet we used, and this one eliminates all degrees of freedom, all translational degrees of freedom, and allows you to have the 3 degrees of rotational degrees of freedom. So I'm going to select ball, and here I'm going to zoom a little bit into my model to show you that you can pick the center of the geometry. So here I'm just rolling my mouse over that cylindrical or circular geometry, and I got the center point highlighted as my connection. I'm going to select the model, and I'm going to move back over into my model. And here actually I've created a reference circle. Actually, it's just a sketch of a circle here, so I could use the connection point on that curve. And it's highlighted. You can see now that that connecting rod moves into position. And select OK, and I can drag that. You can see that it actually helps move everything, but it's still allowing the interference with the model, and it will do that until I actually confirm my next ball joint, and that one is going to be connecting it to the actual propeller. Selecting here and selecting here. That's the preview for it, so it eliminates that previous joint that I added. However, when I select OK, it snaps back into position. So you can see here that I have that whole assembly now working properly. Okay, so what you can do from here on is assemble the other 2 blades. However, I'm just going to open up the final engine assembly and just show you the actual final version of this model. So you can see that all of those propellers have been added and the connecting rods have been added as well. And you can see I can drag that in and out. I have that motion there. To control things, I can drag the hub around and work with that. If I spin around, I also see that all of this is moving from the back using that that master rod as well. Okay, so that's what I wanted to show you in terms of the joints. I'm going to flip back to my presentation quickly and just talk about some editing. So, you know, in the real world, you don't always get everything perfectly the first time. You need to go back in and edit some of these joints. You can do this a number of different ways. So that gap value that you assign to maybe offset a couple of the connection references, you can double-click on the joint name or right-click and hit Modify, and then that value comes up within a little mini toolbar that is available. And here, I'll just circle this for you. So this is basically the Modify tool. So it's not bringing you directly into the dialog box for the joint, but you can enter a new connection, or sorry, a new gap value there. The other thing you can do is edit the actual joint, and I did that in one of the situations when I added the limits to it, and that's a right-click edit to actually bring up that mini toolbar in the edit joint dialog box. You also have a really nice way now of reviewing all of the relationships that you establish. So I'm going to flip quickly to back to Inventor and just show you this inside this model. So you know how we attached everything before. If I was to select that, you can see how it's moving. But I'm going to go to Free Move and drag that out. And if you look carefully, you can see all of these connection lines that are established. And basically that is giving you information as to the relationships between all of those components. If you see there's glyphs here, those little glyphs are little icons basically that are giving you you can see this one is a cylindrical joint type, the ball joint types, all of those. And if you actually select on any of these, you can right-click and you can suppress any of them. You can edit them to get into the actual source dialog box. You can delete them. You can modify them. So it's just another nice way of looking and reviewing the references after the fact. And to clear this and to snap the assembly back into position, just like you would do before with Free Move, you use the update, local update option that's up in the graphic in the quick access toolbar. You can see it's all snapped back together. So those glyphs, again, delete, edit, suppress. The other one actually is show thick, and this is a really nice option. I'm going to flip again back to Inventor. This is an option that is available here in the relationships panel. I've got it circled here now. And you can see that it's grayed out in my situation. And basically what this is telling me is that I actually don't have any thick constraints in my model. So there's no references that have been mistakenly lost or anything like that. However, if there was, that would be black, and I would be able to select it. So I'm just going to roll my mouse over this quickly and show you the tooltip that's available, because it actually does a really nice job in highlighting what you see for a stick component or stick constraint. So you can see here you get that little warning sign, the little caution symbol, and that's identifying that you have a stick constraint and that you'd want to go in and fix it. So if you see this option gray, you don't have to worry about a thing. Everything is fine. But if it is black, you'll want to pay attention to that and resolve any of the references that are missing. So with that, I'm just going to I'll go over and tell you just a little bit more about ASCENT'S AOTG training material. So what we just talked about a minute ago, or the last 60 minutes, was one of the chapters in our actual training materials. That was in the Inventor Introduction to Solid Modeling Training Guide. And in that training guide, with all of the chapters, we have reference to certification material. So many of you have gone out and taken Autodesk certification for Inventor, for AutoCAD, those types of things. We identify all of the content that is covered by the exam objectives in our book, and we do that with the certification logo here. And it tells you which topics and objectives you need to learn. So they're adjacent to the content, so as you're reading through the book, it identifies it. So a really handy way of reviewing for your exam. We also have review questions at the back of each chapter. another fantastic resource to make sure that you have learned the material and are understanding all the topics. We also have instructor tools and instructor slides. So for instructors that want to present all this material using a PowerPoint presentation, we have this all created for our training guides, for the Inventor training material, which also you can access. So we also have listed on our website all of our books. So I've been mentioning Inventor, but there's a lot of different manufacturing books that we have available. So you can look on our website and see all of the topics and content that we have available. I just got a quick screen grab here of the different courses that would most likely pertain to many of you in the manufacturing field. So you can see that we've got a number of different topics in electrical, mechanical, Inventor, as well as the course links for each of those courses. And as Jen mentioned, I will step in here. We have all of that courseware in printed, spiral-bound guides. We call them student guides. We have ebooks, instructor tools, and hot off the press are Inventor e-learning bundles. So basically with the e-learning bundle, you have online access to the content from 4 of our Inventor Autodesk official training guides. So we've taken the content from the guides, we've formatted it specifically for online learning, and we've made it available to users for a 1-year subscription. So that is pretty exciting stuff. And if you want to go to our next slide, just to let you know, everything can be purchased on our Ascent eStore. And that's the first one you see up there, ASCENT'sEStore.com. Also, if you go to our eStore or our website, ASCENTED.com, you can find all the info about our courseware, everything from page count, table of contents, the pricing, and you can also download sample chapters if you want to have a look at those. So if you need to reach us, we've got a phone number there, email address is feedback@ASCENTED.com. We'd love to hear your feedback on presentations like this. If you've got future topics you'd like to see, that would be great to hear. Or any comments you'd like to make about our courseware, we'd love to hear that. And also, we have a blog, and Jennifer is one of our bloggers. So if you go to our Ascent website, theascented.com, right from the home page there, you can click on the blog, and you can